Today on Astronomy Daily, we've got a packed show covering some of the biggest stories in space news. From potential leadership changes at NASA that could reshape the future of American space exploration, to ancient cosmic collisions that rocked our planet millions of years ago. We'll also explore fascinating new developments in space telescope maintenance, get an update on Europe's return to the launch pad with Vega C, and discover what the James Webb Space Telescope has revealed about a mysterious cosmic spiderweb billions of light years away. Plus, we'll look at how our sun's increasing activity is causing unexpected challenges for satellites in orbit, and why this could be just the beginning of a solar storm season that's already exceeding predictions. Let's get started. In a significant announcement that's sending ripples through the space community, President-elect Donald Trump has named Jared Isaacman as his pick to lead NASA. This choice marks a notable departure from traditional NASA leadership, as Isaacman brings a unique blend of private sector experience and actual spaceflight expertise to the table. Isaacman, the 41-year-old CEO of Shift4 Payments, has already made his mark in space history as a private astronaut, having completed 2 missions to orbit aboard SpaceX capsules through his Polaris program. What makes this selection particularly interesting is Isaacman's close business relationship with Elon Musk and SpaceX, where he's invested hundreds of millions of dollars as a key customer of their private astronaut services. If confirmed by the Senate, Isaacman would oversee NASA's substantial $25 billion budget. This appointment comes at a crucial time for the agency, as it continues its ambitious Artemis program aimed at returning humans to the moon, a program that heavily relies on SpaceX's Starship vehicle. The timing of this announcement is unusually early in the presidential transition process, and industry insiders note that Musk's influence and discussions about Mars exploration may have played a role in this early selection. Trump himself recently attended SpaceX's 6th Starship test launch in Texas, highlighting the growing ties between his potential future administration and the commercial space sector. Isaacman's appointment could signal a deeper shift toward commercialization of space activities, potentially accelerating NASA's existing strategy of partnering with private companies. This approach has already transformed how NASA accesses space, though it has raised questions about the future of traditional government-led programs like the Space Launch System. Looking ahead, Isaacman has expressed his vision for expanding space exploration, emphasizing potential breakthroughs in manufacturing, biotechnology, and even new energy sources. However, he'll face significant challenges, including managing NASA's diverse portfolio of scientific missions, some of which have faced recent budget constraints, and balancing the agency's traditional role with increasing commercial partnerships. While we often think of the dinosaur-killing asteroid as Earth's most famous cosmic impact, our planet has faced other massive collisions throughout its history. A fascinating new study has revealed that Earth was struck by not one, but 2 enormous asteroids around 35 million years ago. But here's the surprising part. Despite their tremendous size, these impacts left remarkably little long-term evidence of climate change. The first asteroid, estimated to be between 5 and 8 kilometers wide, created the massive Popogai crater in Siberia, spanning 100 kilometers. Just 25,000 years later, a second asteroid measuring 3 to 5 kilometers struck what is now Chesapeake Bay in the United States, leaving a crater between 40 and 85 kilometers wide. These aren't minor dents. They represent the 4th and 5th largest known impact craters on Earth. Scientists studying these ancient impacts made an unexpected discovery when examining fossil records from the Gulf of Mexico seafloor. Despite the enormous size of these collisions, they found no significant evidence of long-term climate change in the geological record. The Earth essentially shrugged off these cosmic punches, showing remarkable resilience. However, we shouldn't underestimate the immediate devastation these impacts would have caused. In the short term, think decades to centuries, these collisions would have created massive shockwaves, triggered enormous tsunamis, and ignited widespread fires. The impacts would have thrown massive amounts of dust into the atmosphere, temporarily blocking out sunlight and disrupting life across the planet. This research gives us valuable insights into Earth's ability to recover from major astronomical events, while also serving as a reminder of the importance of modern-day asteroid detection and planetary defense programs. After all, while our planet may be resilient in the long term, The immediate consequences of such impacts would be catastrophic for human civilization. Next up today, exciting developments are emerging in the field of space telescope maintenance, particularly for observatories stationed at the Sun-Earth Lagrange point L2, about 1 million miles from Earth. Scientists have designed a novel approach to extend the operational life of these invaluable instruments, potentially saving billions in replacement costs. The James Webb Space Telescope and Gaia, two of our most powerful eyes in space, are facing challenges that could limit their lifespans. While Webb has already suffered some micrometeorite damage to its mirrors, Gaia is running low on fuel after a decade of faithful service. But researchers aren't ready to let these astronomical powerhouses fade away just yet. A particularly innovative solution involves a spider-like attachment designed to service these telescopes without disrupting their delicate operations. This concept could be especially crucial for Webb, which still has many years of potential observations ahead. The challenge lies not just in reaching these distant observatories, but in servicing them without causing damage. One of the trickiest aspects of this maintenance mission is the approach phase. Traditional braking methods using thrusters could be catastrophic. Imagine pointing what amounts to a blowtorch at these sensitive instruments. To address this, researchers have developed new trajectory techniques that combine dynamical systems theory with optimal control theory, creating efficient and safe paths to reach these distant telescopes. The research team has already completed plans for refueling Gaia, while additional engineering work continues for Webb servicing missions. These developments represent a significant shift in how we think about space telescope longevity, moving from disposable instruments to serviceable ones that could potentially operate for decades with proper maintenance. Europe's Vega C rocket is poised to make its highly anticipated return to service, marking a crucial moment for European space independence. The 35-meter rocket has been fully assembled at Europe's spaceport, with its payload, the Sentinel-1C satellite, now securely mounted at the top of the stack. As ESA's compact launcher specialized in delivering payloads to polar orbits, Vega C works alongside the recently debuted Ariane 6 to ensure Europe maintains its sovereign access to space. This upcoming mission is particularly significant as it represents Vega C's return after a 2-year hiatus and will be the 25th flight of the Vega rocket family. The rocket's assembly is a marvel of engineering efficiency, featuring 4 distinct stages. At its base, the P120C first stage stands as one of the world's most powerful single-piece solid-fuel rocket motors. This component is shared with Ariane 6's boosters, creating a cost-effective synergy between the two launch systems. The second stage, the Zafiro 40, comes equipped with an improved nozzle design and has undergone extensive testing to ensure reliability. When launch day arrives, the first 3 stages will propel the rocket skyward in a carefully choreographed sequence lasting just 8 minutes. The final stage, known as AVUM Plus, will then take over, performing a series of precise orbital maneuvers before delivering Sentinel-1C to its designated orbit approximately 1 hour and 50 minutes after liftoff. This return to flight represents more than just another launch. It's a testament to European space capability and determination. With both Vega C and Ariane 6 operational, Europe strengthens its position in the global space launch market while ensuring continued independent access to space for scientific missions and satellite deployment. Let's get an update from the JWST now. The James Webb Space Telescope has once again demonstrated its extraordinary capabilities, this time by peering into the cosmic web-like structure known as the spiderweb protocluster. Located an astounding 10 billion light-years from Earth, this massive gathering of galaxies offers us a glimpse into the universe as it appeared just 4 billion years after the Big Bang. What makes this observation particularly exciting is that the Webb telescope has revealed previously hidden details of this cosmic metropolis in construction. While earlier studies had identified around 100 galaxies in this region, Webb's infrared vision has uncovered even more galaxies that were completely obscured by cosmic dust and gas. The telescope's ability to penetrate through these cosmic veils has provided astronomers with unprecedented views of hydrogen gas distribution and galaxy formation processes. Surprisingly, the research team found that many of the previously known galaxies weren't as dust-filled as initially thought, challenging our understanding of how these early cosmic structures evolved. One of the most remarkable aspects of this discovery is that these impressive results were achieved in just 3.5 hours of observation time. The findings suggest that the growth of these early galaxies might not have been primarily driven by dramatic events like galaxy mergers or interactions, but rather through a more gradual accumulation of gas across the structure. This massive cosmic city serves as a crucial laboratory for understanding how the largest structures in our universe came to be. By studying these adolescent galaxies in the process of forming one of the universe's largest structures, astronomers can better understand how the mature galaxy clusters we see in the local universe evolved over billions of years. As you may have noticed, our sun has been flexing its muscles lately, and the consequences are being felt in Earth's orbit. In early November, 3 Australian satellites from Curtin University's Binar space program met an unexpectedly early demise, burning up in Earth's atmosphere just 2 months into their mission, far short of their planned 6-month lifespan. This premature end wasn't just bad luck. It's a direct result of our sun entering an extraordinarily active phase, causing Earth's upper atmosphere to expand and create increased drag on satellites in low Earth orbit. The Binar satellites, whose name fittingly means fireball in the Noongar language, aren't the only victims of this enhanced solar activity. Satellite operators worldwide are grappling with similar challenges as solar activity surges to levels more than 1.5 times higher than predicted for this point in the current solar cycle. The effects of this increased solar activity are visible even from Earth, with auroras appearing more frequently and closer to the equator than we've seen in the past 2 decades. But the real drama is playing out in space, where satellites face multiple challenges. Beyond the atmospheric drag issue, the heightened solar activity bombards satellites with charged particles that can damage their electrical components and disrupt their operations. While larger satellites like the International Space Station and Starlink constellation can use thrusters to maintain their orbits, smaller satellites like the Binar CubeSats are completely at the mercy of these solar effects. This situation particularly impacts university and research satellites, which often lack the sophisticated propulsion systems of their larger counterparts. Looking ahead, space weather forecasters predict this intense solar activity will likely continue until 2026, with solar minimum not expected until 2030. This presents a significant challenge for satellite operators and underscores the growing importance of accurate space weather forecasting in our increasingly space-dependent world. And that's a wrap for today's episode of Astronomy Daily. From Trump's surprising NASA pick to ancient asteroid impacts, space telescope innovations, and our sun's dramatic effects on satellites, it's been another fascinating day in space news. I'm Anna, and I want to thank you for joining me. If you're hungry for more space and astronomy updates, head over to astronomydaily.io, where you'll find our constantly updating newsfeed, free daily newsletter, and all our previous episodes available for streaming. Don't forget to join our growing community on social media. You can find us as Astro Daily Pod on Facebook, X, YouTube, Tumblr, and TikTok. Keep looking up, and I'll see you tomorrow with more stories from the cosmos.